What if I told you that every AI model you've ever used has been wasting 80% of its brain power relearning the word the? DeepSeek just fixed that, and it changes everything. Here's the dirty secret nobody talks about. Modern AI is brilliant and catastrophically inefficient. Every time ChatGPT sees the phrase United States, it burns through millions of calculations to figure out what those words mean. Every single time. It's like having a PhD mathematician who needs to recount his fingers before doing calculus. We've been scaling AI the brute force way. Bigger models, more parameters, more GPUs. GPT-4 has over 1 trillion parameters. Running it costs more than powering a small city, and we've hit a wall. Not a technical wall, an economic one. The industry's answer, mixture of experts, or MOE. Think of it as hiring 64 specialists instead of one generalist. When you ask about Python code, only the coding expert wakes up. When you ask about history, only the history expert activates. Clever, right? DeepSeek v3 uses this. So does Grok. It cuts costs by 80%. But here's what nobody's saying. It's still fundamentally broken. Because even with MOE, these models have no real memory. Zero. Zilch. Imagine you're a detective. Every time you see a suspect's face, you have to reconstruct their entire profile from scratch. Height, weight, criminal record, even though you've seen them 1,000 times. That's what LLMs do with common phrases. New York City, machine learning, for example. These appear billions of times in training data, yet the model treats each occurrence like it's the first time. It's computational insanity. Your brain doesn't work this way. When you see Einstein, you don't rebuild the concept from atomic particles. You have instant recall. That's memory, real memory. And until now, LLMs didn't have it. Enter ENGRAM, DeepSeek's nuclear option. ENGRAM stands for Efficient N-gram Representation and Memory. But forget the acronym. Here's what it actually does. It gives AI a photographic memory for patterns. Instead of recalculating common phrases, ENGRAM stores them in a lightning-fast lookup table. Think of it as the difference between solving 2 plus 2 every time versus just knowing it's 4. The philosophy is brutal in its simplicity. Stop wasting your brain on memorization. Use it for thinking. Here's the technical magic, simplified. Traditional LLMs process every single word through 50-plus layers of neural networks. Every word, even the, even and. It's like using a supercomputer to check your spelling. ENGRAM creates a shortcut. It identifies the 128,000 most common word patterns, engrams, and stores their meaning in a massive hash table. When the model encounters United States, it doesn't compute, it looks up. A hash table lookup is constant time, instant. Doesn't matter if you have 1,000 entries or 1 billion. But here's the genius part. ENGRAM doesn't blindly trust its memory. It has a truth detector, a gating mechanism that checks, does this stored pattern actually fit the current context? If you're reading about New York pizza versus the New York Stock Exchange, the same words mean different things. The gate catches that. It suppresses irrelevant memories and amplifies relevant ones. No hallucinations, no noise. Now you might be thinking, why not make the entire model memory? Because memory is dumb, fast but dumb. It can't reason, it can't create, it can only recall. DeepSeek ran the numbers. They tested models from 16 billion to 671 billion parameters. The sweet spot? Allocate 20 to 25% of your model's capacity to memory. The rest? Pure reasoning power. It's exactly like your brain. You don't want 100% memory, that's just a hard drive. You don't want 0% memory, that's amnesia. You want balance. And by finding that balance, AI just took its biggest leap forward yet.
Let's continue with the results. DeepSeek trained a system called ENGRAM on 262 billion tokens. Then they tested it against the traditional models that everyone else uses. The results are absurd. For language modeling, it's 11% better perplexity. That translates to 11% more accurate predictions on every single word. For knowledge and reasoning, an 8.7% improvement on graduate-level exam questions. For reading comprehension, even on texts up to a 400-page novel, a 6.3% boost. And for code and math, problems that stump most humans, it's 9.2% better. But here's the wild part, the part that shouldn't be possible. ENGRAM was designed to save memory, but it accidentally made the model smarter at reasoning. So why does it make AI smarter? Here's the part that breaks everything we thought we knew. In traditional models, the early layers, the very foundation of the system, waste 60 to 70% of their computational budget just reconstructing trivial patterns. Things like the cat sat on the... The model is literally burning millions of operations just to understand basic grammar you learned in 3rd grade. With ENGRAM handling that grunt work, those early layers are suddenly unemployed. And what do they do with their newfound freedom? They start thinking like the deep layers. DeepSeek proved this with what are essentially brain scans for AI. What they found was shocking. In ENGRAM models, layer 5 starts behaving like layer 35 in a traditional model. It's doing abstract reasoning, multi-hop logic, global context synthesis, tasks that normally require 30 additional layers of processing. Think about what this means. You're not adding depth, you're revealing depth that was always possible, but was just buried under busywork. It's like discovering your accountant is actually a strategic CFO. You just had them filing paperwork for 20 years. The model gains emergent intelligence without adding a single new parameter. That's not optimization, that's an architectural revolution. Now let's talk about the test that separates the pretenders from the contenders. Long context reasoning. It's called the needle in a haystack benchmark. You bury one critical sentence in a 100,000-word document, about the length of a 300-page legal contract. Then you ask the AI to find it and use it. Traditional models? They get it right 73% of the time. That means 27% of the time they're billing you for work they got wrong. ENGRAM? 94% accuracy. But that number doesn't even tell the whole story. It's not just finding the needle, it's maintaining coherent reasoning across the entire haystack while doing it. The reason for this massive jump is that ENGRAM isn't reprocessing every word like a monk copying manuscripts. It's pattern matching stored phrases at CPU speed, which frees up the attention mechanism, the model's most expensive operation, to focus on actual comprehension. For industries drowning in documents, legal, medical, finance, this isn't a feature, it's a business model disruptor. You're looking at an AI that can actually read a 400-page merger agreement and catch the liability clause on page 287. Not hallucinate it, not miss it, actually catch it. But wait, you're thinking, doesn't a giant memory table slow everything down? Nope. DeepSeek designed ENGRAM to be smart about infrastructure. They offloaded the memory to the computer's main RAM instead of the precious, expensive GPU memory. The performance hit? Less than 5%. You get a 10% smarter model for a 5% speed cost. That's not a trade-off, that's a steal. And because it's open source, every AI lab on Earth is reverse engineering this right now. So what does ENGRAM actually mean for the future? It means we've stopped building bigger hammers and started building better tools. It means AI can finally separate memorization from reasoning, the same way your brain does. The next generation of models won't just be larger, they'll be fundamentally more efficient, more capable, more human. DeepSeek didn't just make these models more powerful, they made them make sense. And if you're building anything with AI, you need to understand ENGRAM, because this isn't an incremental improvement, this is a paradigm shift, and it just went open source.